Hello everyone, I'm Anand Parekh of the Sparks Foundation Graduate Rotational Internship Program. My field of interest is data science and business analytics, and this is the task one of the same. The task here is to create a simple linear regression model between number of hours of study and the marks scored by student, and to predict the score if a student studies for 9.25 hours. So let us begin with importing the libraries. The libraries that I'm going to use are NumPy, Pandas, Seaborn, and Matplotlib. So let me denote my data frame to be df, and using the Pandas library, I'll use import them. So df.head gives us the head of the data frame, and if we do not give the variable 10, it will give us by default the first 5 entries. But I have made use of 10, so it will give us the first 10 entries of the data frame. df.info provides us the information regarding the data frame. So as you can see, there are two columns, hours and score, and the data type for hours is float, and for score it is integer. As you can see, it is 2.5, 5.1, 3.2. It's a decimal value, and hence it is a float object, float type, and these are just integers. 25 non-null implies that there is no value left empty, implies that the data frame is complete and there is nothing missing out of the data frame. df.max provides us the maximum value in the data frame. The maximum number of hours is 9.2, and the respective score is 95. Similarly, df.minimum gives us the minimum score and the minimum number of hours, which is 17 and 1.1. So let us make an empty list of result. Okay, so for score in df scores, so that if the score, I'm assuming if the score is less than 35, the student has failed the exam, or if the score is above 35, the student has passed. So therefore, if the score is below 35, I'll add the item fail to the result, which is an empty list, and I'll similarly add pass if the score is above 35. So I'll make a new column, df result equals result. The data frame now looks something like this. As you can see, 21 is less than 35, therefore the student has failed. 47 is greater than 35, and thus the student has passed. So on and so forth. Since the result column is just a binary thing, just like 0 and 1, we can do a count plot and get to know that 9 students have failed the exam, while 16 of them have passed out of the total 25 students. Let us plot a scatter plot along between the variables hours along x-axis and scores along y-axis using Seaborn. As we can see, the plot is pretty much linear, and hence we'll use linear regression model. So let us go further. Let me call my y variable to be scores and x variable to be hours. The reason why I'm giving here two square bracket instead of one is that if we just make use of one, it will give us an error that expected two-dimensional array but received only one. And to avoid that, we are making use of two square brackets. So let us import train test split, and I'm splitting my test size at 0.3. That means 70% of my data is going to be used for training and modeling. 30% of it is being used for testing the data. Random state is 101. If you want to get the same result as that of mine, you can make use of random state 101. So let us import from sklearn.linear model linear regression. Let me call linear regression to be LM, or linear modeling. So first, let us fit the X training data and Y training data and find a particular fit. So lm.fit does the job. So print coefficients lm.coef. So as we can see, there is only one coefficient, which is 9.966. It is close to 10. As the name suggests, it's a linear regression. That means we are trying to find a line that connects all the data points with minimum error. So the basic equation for a line is y is equal to mx plus c. M is the coefficient lm.coef times x plus c, which is the y-intercept. So I'll call all my predictions to be lm.predict x test. So from the model, we have found out our coefficients, and now using the model, we are predicting the values for x test. So again, let me just make use of matplotlib to make a scatter plot between our hours of study and scores. And let me just overwrite it with our line. So along the x-axis we have line, along the x-axis we have our hours of study, and along the y-axis it is line. Line is basically our model which is predicting the values. So as we can see, uh, at if a student studies for 6 hours, our the actual data point is correctly corresponding to what we have predicted, which is close to 60. Just for the verification purpose, let us go back and see 5.9, 62. That means our model is working fine. As this is a simple and small data set, we can do this, but in real life the data sets are huge and doing that is quite difficult. So let me call another data frame to be small data frame or SDF, where I give my X test values. The X test, as we can recall, 30% of our data set is test is for testing purpose, which is 2.5, 7.7, so on. And Y test is the actual Y values of the data set. Y pred is basically the predictions that our model has done. So if a student studies for 2.5 hours, his score is 30, but our model is predicting 27. If a student studies for 3.8 hours, the actual mark scored is 35, but our model is predicting 39, which is a little higher. The objective of our task is to predict the score if a student studies for 9.25 hours. So let me call hours to be 9.25, predicted score to be lm.predict hours. So I have given it in the form of a statement. A student who studies for curly brackets hours scores, again curly brackets. Formatting, it will give hours 9.25 and a predicted score value in this. So a person who studies for 9.25 hours scores 94.29. So as you can just scroll up to find out, a person who studies for 9.2 hours scores 95, and a person who studies for 9.25 hours scores 94.29. So as we can see, a marginal difference of 0.25 hours doesn't make a huge difference in the score. So from sklearn, let us import metrics. This is to evaluate the performance of our model. So MAE is mean absolute error, MSE is mean squared error, and RMSE is root mean squared error. Absolute error is 5.86, squared error is 41.63, root mean square is 6.42. So as we can tell that model is performing well because the error is just 5.86. This is a small model, so this is a small data set, so our model is working fine. That is it from my side. Thank you very much for listening.